Good morning, everybody. I know it's almost lunchtime, so I try to be as concise as possible, but also effective. I'm Corrado De Gioia Carabellese, project manager from Frascald. And with this presentation, I would like to present you some innovative solution for this high temperature market with the high temperature compressor, both reciprocating and screw compressor, what we are delivering now in this high temperature application. We will see just a brief overview about our company, where we are located around the world. Just an introduction about what is the situation now about regulation in Europe. That is a big topic nowadays because many changes are going on. So we need to understand the situation now. Our solution before starting from reciprocating compressor, smaller sizes, going to screw compressor for the biggest sizes and application with very high capacities. We are Frascald, we are compressor manufacturers. We not only supply manufacturer, but we are also trying to share our experience to customers in the entire customer journey, from the very beginning for the selection of the refrigerant that nowadays is a big topic, to the very end of the journey. We have many locations around the world. We try to be in the world where you need. So we have production facilities, not only in Italy, where we have our headquarters, but also in China, assembly facility in India, and many sales facility around the world, USA, and a new one also in Vietnam. What is the situation now? We have in Europe, we are a little bit ahead regarding the regulation. We have seen a couple of years ago with the Green Deal, there is this very ambitious goal of in the 2050, the net zero, decarbonize the Europe, with intermediate target of 55% reduction within 2030. These are very strong commitment from Europe, and it's not easy to reach these limits without proper incentives from policymaker. This year, at the beginning of this year, they finally took a decision about F-gases with a strong phase down starting from 2025 with a complete phase out by 2050. And there is also strict regulation about the export. So it's not only for our market, but also for the export outside Europe. And a big question mark is related to the REACH revision. There is a question mark related to the year. I think we will have an answer probably 2027, 2028, not now, luckily. But yeah, we need to follow these updates, because could be very complicated, because at the moment, apart from the refrigerant side that we have, of course, a natural solution, from a component perspective, we don't have at the moment alternatives for all the material that we use inside the compressor, but not only the compressor, also in the other components of the plant. This is an overview about the heat pump market. This is the last release from IPA. We have seen a slightly decrease in 2023, and they have reported also some weeks ago another decrease in 2024. Why this? We need support from policymaker. Regulation need to provide incentives to adopt this solution, especially in countries when electricity has a strong impact on the bill that we all pay. And there are a huge potential, because we have many markets in which we can put our solution, our heat pumps, to achieve all the targets that we all know. I don't have to repeat them, but there are many applications and with a huge potential in the future years. This is just to have an overview about the temperature level that we are facing now. In the past, we were used to talk about high temperature, referring to temperature below 100, maybe close to 100. Now, for us, high temperature is something more, is something closer to 150 and even higher. And why we are trying to reach that level? Because there is a big market in the process heating related to temperature up to 200. We have another question mark here because we need to understand what is the real limit of our technology and what is the starting point of other technology like steam compressor that are, of course, more interesting for even higher temperature. And we will see in the next slide, we have very interesting applications up to 165, 170 of living water fluid, the temperature of the fluids. Another overview of some application from process steam, drying processes, and also this one, the last one, it's very interesting, especially in Italy. You know, we have old buildings. We are a little bit behind Northern Europe. So we need to replace a very old gas boiler. We just replacing the gas boiler with an heat pump. So we need to reach in this old residential building the same temperature you reach with the gas boiler with an heat pump. So it's very interesting, this application with the propane up to 80 degrees Celsius. This is a brief overview of the entire range we are developing. We have already developed for the high temperature application. It is mainly related, there is a shift from reciprocating to screw compressor based on the size and the capacity that you need. So starting from reciprocating compressor, small reciprocating with 4 cylinders up to 8 cylinders, and switching to screw compressors for capacities for displacement up to almost 1,000 cubic meter per hour. And of course, this is more for application with the big capacity, which is needed a very high temperature. This is the product we are developing for reaching above 150 degrees Celsius. Starting from the compressor, the reciprocating compressor series, this is an overview. On the bottom, what we have, what was considered standard before a couple of years ago. So propane up to 65 degrees Celsius living fluid temperature, and isobutane, ZD, and special mixture between hydrocarbons. And what we have now is something even higher with propane up to 80 degrees Celsius delivering water temperature. Even higher. This is the official limit, but we are still testing above these limits. Isobutane application up to 110 degrees Celsius. More using different kind of refrigerant, basically to keep the same pressures of the other. So up to 130 and 140 with the isopentane and ZD. This is very interesting because ZD, it's A1. So for those who are a little bit afraid of flammability, this is a good solution. We don't know in Europe, maybe of course outside Europe in the next few years, we need to understand if in Europe it could be a feasible solution. What we have done to reach these new levels, we have modified many of the components, internal component of the compressor, without changing the shape, because we want to reach these new limits without changing the body of the compressor. We want just to change the compressor without bothering you with system modification because of bigger components. So what we have changed is everything inside the compressor. We changed the motor. We have increased the efficiency. We have shifted the temperature level of the motor. We have changed other critical components, the valve plates, trying to optimize even more the application with natural refrigerants, internal valve, and so on. And we are also doing main evaluation to further increase the efficiency of the motor. using permanent magnet solution, changing the rotor of the motor. With the LSPM technology, is still we can deliver this solution, taking a step forward with the IPM technology to potentially reduce cost and increase the efficiency at the same time. We have also changed the standard oil we choose with the objective to withstand this very harsh condition, burdensome condition due to the high temperature, discharge temperature, but also for the high pressure. This is, we'll go very quickly. This is, you can find these envelopes that are already released in our selection software. It's up to 35 degrees Celsius evaporating temperature, and 80 degrees Celsius, the one released, we have tested even more. This is just to have a reference of the capacities that we can reach, and the COP target with our high temperature series based on the climate. So Northern Europe, maybe you are more interested to very low outside air temperature. So we can imagine evaporating temperature down to -25. In Central Europe, so for example Germany, maybe we are interested in dimensioning with the -10 evaporating temperature because of course higher outside air temperature. And in Italy, Spain, all these countries with slightly higher outside temperature, 5 degrees Celsius with the target COP, and heating capacity we can obtain. This is an extension of the standard envelope we are developing for a very interesting application that I like to call booster. So we have a very high temperature heat source, so we are able to reach very high evaporating temperature and even higher condensing temperature. This was done with isobutane in the past. We can do it now with propane with a 50%, so 50, reducing capacity, of course, because of the pressure that are completely different. So if you want to save a lot of capacity, instead of using 100 cubic meter per hour compressor with this solution, with propane, you can reduce down to 50, that is half. And this is a further extension. So before, what we have seen before was the previous limit of isobutane. So if we using this high temperature series, we can extend the previous limit of isobutane up to 115 degrees Celsius condensing temperature and 50 degrees Celsius evaporating temperature. So there are special applications with a very high heating source temperature. But yeah, it's very interesting, and there is a lot of demand related to this application. Switching to screw compressor. So in this case, we are interested in even higher capacity. Again, what we had until a couple of years ago was a screw compressor for propane, for example, to deliver water up to 55 degrees Celsius, and isobutane, ZE, and so on, HC blends, also in this case, up to 90. We are developing a new compressor for higher temperature with propane to achieve a 65, more or less 65 degrees Celsius leaving fluid temperature. What is interesting here is that there is a lot of demand for reversible heat pump application in which they want to reach very high efficiency both in heating and in cooling. So we have developed this solution with a variable built-in ratio to optimize the efficiency in both conditions, heating and cooling. Again, we have a similar limits considering higher temperature with isobutane, also in this case 110. Butane or ZE, similar application envelope, up to 130, and even higher, the one that I mentioned before, up to 165 leaving fluid temperature. So the condensing temperature is even higher. Okay, again, many modifications. I don't want to go through all details. What you need to know, we have developed and tested, validate a lot of new components to make The first point for this development was the reliability, because we cannot provide a solution for this new high temperature application without being sure of the reliability of the component that we are providing. So reliability first, efficiency second, but at the same level of importance. These are just to give you an overview of what we have in field test. Is not what I presented are not only theoretical evaluation. We have many field tests, and what we are seeing is an increase in demand related to this high temperature application, mainly for this level, because of I think above 150 many customers would like to do would like to have this application, but are a little bit afraid now. So up to 150, we see many applications. We have more than 3 projects now, both with hydrocarbons and HFOs. HFOs mainly outside Europe. And we are also collaborating with technical institutes for the projects above 150 that requires a different design. So as you increase the temperature, as you can expect, there are different design solutions. So to give you an idea, to reach 150 degrees Celsius, the required modification of the components are more or less between around 20 components that need to be modified to reach this level. Maybe around 35 components, different components specifically designed for this temperature level. And yeah, we are in a design phase for the very, very high temperature, because of course is not an immediate implementation. This is why we are collaborating also with technical institutes to validate the solution and deliver it fully tested, fully validated in a safe environment, let me say. And we expect to finish this field test within 2024, maybe the beginning of 2025, and release the next year the series with these high temperature fluids. So we have seen a big question mark related to regulation, even if now with the F-gas there is more, we are more certain about the future. We don't know outside Europe. What I like to say is that we not only as Europe go in a certain direction, we need to bring, we would like to bring also the other countries so that we are all aligned in the same direction. There is a huge demand of heat pump for this high temperature application, process heating, industrial sector, space heating, also residential sector. We have seen commercial sector. So there are lot of opportunities in this market, so this is why we are focusing a lot in this sector. We have developed this dedicated high temperature series, not only propane, because now it's propane the main refrigerant in the demand of everybody, but we have also other solutions, not only with hydrocarbons, with natural refrigerant, but also with HFOs. And yeah, it's very, very interesting, this application over 160. We will not see it, I think, in few years, but maybe it's a medium-term project. But it's really interesting, and we have the solution. We are developing this solution. So thank you very much. You can reach me with my email or through LinkedIn, as you prefer. And have a nice day. Thank you.